Hey guys, we are in chapter 2. We're looking at section 2.8, and we're going to be proving angle relationships. So today we're going to talk about a lot of different rules slash postulates and theorems that we're going to accept and use and going forward as we talk about angles and prove things. So the first one is the postulate 210, which is the protractor postulate. Basically what it says is we are able to measure angles. It says that we can measure angles. So let's see what it says. It says, given an angle, the measure can be put into a one-to-one correspondence with real numbers between 0 and 180. And so as you see here, we can basically we can talk about measuring angle. This reminds me of the segment measurement postulate. I don't know if you remember that from the last section, but it's very similar. Gives us the power to measure angles. The angle addition postulate is one that I think we're probably going to use a lot of. And basically it says, if you have this angle right here, you've got this angle, and we'll call it angle ABC, and you have some random point D that is in the interior of ABC, then the following thing happens. Angle ABD plus angle DBC, the measure of angle ABD plus the measure of angle DBC is equal to the measure of the whole thing, the measure of angle ABC. And that's what you see here. So we're talking about the measure of these angles adding up to be the measure of the larger angle. Let's use this concept to see if we can solve the following problem. So as I look at example 1, it tells me that if I can find the measure of angle 1, find the measure of angle 1 if the measure of angle 2 is equal to 56 and the measure of angle JKL is equal to 145. Well, as you know, as we've been proving things, we like to think about why something is true. So I'm going to start off with the thing that we just learned. We learned that the measure of angle 1, right, plus the measure of angle 2 has to be that measure of angle JKL. So I'm going to write that down right here. All right. So now that I've got this established as a fact, this is what this is angle addition postulate, right? The next thing I'm going to do is do some substitution. So I've given this equal value and I'm given this equal value. So now I've got that the measure of angle 1 is equal to 56, measure of angle 1 plus 56 degrees is equal to 145 degrees, and that would be by substitution property of equality. The next thing I'm going to do is basically go through and do subtraction property of equality, subtracting 56 from both sides. And when I do that, I'm going to substitute in 56 minus 56 is 0, so I'm not going to put anything there. And 145 minus 56 is going to give me 89. So I know that the measure of angle 1 is 89 degrees. Here are some theorems that you should be comfortable with in terms of concept, but let's make sure that we understand exactly what's saying. Remember, theorems are concepts that can be proved, usually with postulates or axioms. Postulates, we just accept them as true. So let's check out this theorem that can be proved, all right? If two angles form a linear pair, we remember forming a linear pair means two angles come together to give me a straight line. If two angles form a linear pair, then they are supplementary angles. Seems kind of obvious, right? But we can prove this. We can prove that if you've got two angles that are linear pairs, and when you come together, they're going to be supplementary. And remember, supplementary means two angles that add up to 180. And here we're going to have a similar idea with complementary angles. So if we have a situation where the non-common sides of two adjacent angles, that was a mouthful. So here are two angles that are adjacent. Adjacency means they share a side, so that's what makes them adjacent. And if the two non-common sides, this guy over here and this guy over here, form a right angle, so if that makes a right angle, as we see it's there, that's not good, as we see it forms a right angle, okay, then the angles are complementary. It almost seems like, duh, of course it does, but we get this again from angle addition postulate. Measure of angle 1 plus the measure of angle 2 has to be the measure of the whole thing, which is 90, because we know that the two non-common sides form a 90-degree angle, and therefore by definition of complementary angles, well, bam, bam, we got that those angles are complementary. This example asks us to consider this idea when we have two, in this case, we're going to be dealing with complementary angles. So it says, using a transit, a surveyor sights the top of a hill and records an angle measure of 73. What is what is the measure of the angle the top of the hill makes with the horizon. And so we know horizon is this way. Here's the top of the hill. And then they want us to also justify each step. So the top of the hill is here. When the surveyor figures out the angle that he actually figures out or she actually figures out, whichever, would be here. And this took me a little bit of time to realize that we were talking about the angle that the hill makes with the vertical axis. This is not something that I would have thought about naturally. But once you get a picture drawn of your geometric situation and you put in correct information, a lot of information is just going to come out. So now I see that angle 1 is 73, angle 2 we need to figure out, but it doesn't seem too hard because I know that the sum of angle 1 and angle 2 is going to be 90 degrees. I should say that better. The measurement of angle 1 plus the measurement of angle 2 is equal to 90 degrees, all right? So in a sense, we're kind of given that information because we've got a vertical and horizontal raise, and we get that, right? And so the next bit of information is that we've got this given information. The fact is that angle 1 is equal to 73 degrees, and we can put that 73 degrees there by substitution. The next thing that I would do here is I'm going to subtract. Use the subtraction property of equality to subtract on both sides of my equal sign, and I get that the measure of angle 2 is equal to 90 minus 73, which is going to give me 17. So the measure of angle 2 is 17 degrees. And though if you are asked to justify each step, you should write down the things that we said, so let me do that. There we go. There's our justification for each step. And now we can move on to more theorems. The cool thing about these theorems is that you have seen them before we dealt with them in terms of like arbitrary concepts, and we dealt with them in terms of segments. So here we go. We're dealing with them in terms of angles. So the reflexive property, the angle 1 is congruent to itself. Symmetric property, if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. And then the transitive property, if angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, then clearly angle 1 and angle 3 are congruent. And the symmetric property, again, this is the proof of the symmetric property that one can look at. If angle A is congruent with angle B, then angle B is congruent with angle A. You could start by the given information. By definition of congruence, these guys are equivalent. Use the symmetric property of equality. You can switch them. Thus, you can get this here. And it's not that deep. It seems almost frivolous, but it is an important concept to be able to understand that we can't just jump to symmetry without using the symmetric property of equality with the numbers. And so we get numbers here when we talk about the measure of the angles. Subtle, but good to know. All right, so here, these guys are important. Congruent supplements theorem. So basically what this is saying is, hey, if I'm walking down the street and I'm number 1, and I recognize, oh my gosh, 2, I'm supplementary to you. So cool. And then 3 says, oh my gosh, I'm also supplementary to 2. So cool. What that tells me is that we are equal. All right. So if one angle is supplementary to an angle and then another angle is supplementary to that same angle, then those two are equal. There's a little bit more here. It says angles supplementary to the same angle or two congruent angles are congruent. So what that means is if I'm supplementary to angle 2, and then I know for a fact that angle 4 also equals angle 2. Let's say I knew that. And then 3 is supplementary to angle 4. So these guys are congruent. I'm supplementary to 2. 3 is supplementary to 4. We can then talk about our equality as well. And I like here they gave us an abbreviation. This reads angles supplementary to the same angle or congruent angles are congruent. All right, and they give us a little example here. Let's look at this next guy. This is going to be very similar, but we're talking about complements. So congruent complements theorem, same idea. Let's think about it. If I am 4 and I am complementary to 5, and 6 is also complementary to 5, that tells me that I am equal to 6. So let's see how it's written here. Angles complementary to the same angle or two congruent angles are congruent. So again, we can think about it just the way I said, or if we throw in this angle here, let's call it 7, and 4 is complementary to 7, and 5 is complementary to 6. And we know that 5 and 7 equals, then we know that angle 6 and 4 are equivalent as well. So here's a little proof, and I am going to skip over it. Don't feel bad. I think it is worth reading through, so I'm going to leave that for you. But I am going to skip over it and just to honor our time together, so I can share some information. But this is pretty good stuff. Over here in example 3, we're going to prove. We're going to our proof is going to use the idea of congruent complements or supplements, and so we're using the theorems we just discussed. Here's what I'd like to do. Let's highlight the area that we're working in. We are told that we're going to prove that the vertical angles 2 and 4 in the photo at the left are congruent. So our goal, and I like to sometimes highlight what I'm looking for in red, is to prove that 2 and 4 are congruent. Let's talk about what we have. And so in the given, I'm going to do it in green. We are given that angle 2 and angle 4 are vertical angles. Got it? 2 and 4 are vertical angles. And then we're given that angle 2, we need to prove that angle 2 is equal to angle 4. What I'm thinking about is that same problem we just did, where if I had angle 1 being supplementary to 2, which it is, and then I had angle 1 being supplementary to angle 4, which it also is, then by that theorem we can say that angle 2 and angle 4 are equivalent. So let's think about how we can do that. So one of the first things we'll do is to write down the given information. So angle 2 and angle 4 are vertical angles, and I'll write vert angles like that. Sometimes abbreviations are really helpful, so I'm going to abbreviate when I can, and that's just given. The next bit of information I want to talk about is the fact that when I have these two angles here, 1 and 2 and 1 and 4, angles 1 and 2 and angles 1 and 4 are linear pairs, right? Let's write that down. Okay, so these guys are linear pairs, and that's by definition of linear pairs. And so we learned something today about linear pairs. Do you remember? I'm going to scroll back up and take a look at it. It was like one of the first things we talked about. It was, let's see, if two angles form a linear pair, then they are supplementary angles. And if two non-common sides, so we can basically, this is the one we want to say that they're supplementary angles, right? So let's do that. So angle 1 and angle 2 are supplementary, right? And angles 1 and angle 4 are also supplementary angles. Let me put a little angles here so it's kind of a complete sentence. All right, and why is that true? Do you remember? That was the postulate over here. It says if you have a linear pair, I'm going to write it this way: linear pairs are supplementary. And that was the postulate that we had earlier. Linear pairs are supplementary. Good. So now that we've got that, I think we're almost home free, because we know something about supplementary angles. We know that supplementary angles have what quality? Well, specifically, we've got this theorem, right? This is the quality that we're talking about. This congruent supplements theorem. It says angles supplementary to the same angle or to congruent angles are congruent. And I think that's our take home. So let's go ahead and take this and use it. So here we have, back down here, we've got an angles that are supplementary to the same angle, right? So we've got exactly what we need. So then these guys are congruent. So I can say that angle 2 is congruent to angle 4. And that was by that theorem we just talked about, which is angles supplementary to the same angle or congruent angles are congruent. And there ends our proof. Let's go ahead and take up the rest of this example or the rest of this lesson in another video. All right, I'll see you in a moment.